Hello guys, welcome to another episode of GeeklyEDU. My name is Eddie, and today we'll be talking to you about the alternating series test. So let's imagine that we have an infinite series that looks like this. Okay, it's just a regular infinite series where a sub n looks like this. So -1 to the power of n times some b sub n, or a sub n is equal to -1 to the n plus 1 times b sub n, where b sub n is greater than or equal to 0. And basically, what this test is going to tell us is that if we can prove that the limit when n approaches infinity of b sub n is equal to 0, and that the sequence b sub n is decreasing monotonically, then we can conclude that the series converges. Okay, so very simple. If we find a series that looks like this, where a sub n is either this or this, and we can prove these two conditions, we can guarantee convergence. So let's look at an example. Let's imagine that we have this series. Okay? Now, if we try to expand the series to see what it looks like, it's going to look something like this. So we don't really see a pattern, and at this point, we're not necessarily interested in if it converges, to what value will it converge, but just whether it will converge or not. So right away, we tell that this is a n. Well, if that is a n, so a n is 1 over n times -1 n to the power of n, according to my definition over here, b sub n is 1 over n. And once I have identified b sub n, I will go ahead and see if the two aforementioned conditions are valid or not. Number 1, I need to take the limit as n approaches infinity of b sub n. And indeed, we can tell right away that it is equal to 0. So that's a good sign right there. And then the second one, we need to be able to prove that b sub n decreases monotonically. There are a few ways to do that. You can graph it. Since n is greater than 1, then we can already tell that the values that we're going to get are 1, 1/2, 1/3, 1/4. So we're, it's smaller and smaller. We can take a derivative and realize that the second derivative is always going to be negative. The first derivative is always going to be negative. So that shows a monotonic decrease. There are different ways to go about it, but this is true. Therefore, since we have an infinite series, a sub n, where a sub n looks like a sequence times -1 to the power of n plus 1. And this accompanying sequence b sub n satisfy the two conditions of approaching 0 as n approaches infinity and being monotonically decreasing, we can safely conclude that the initial infinite series converges. And this is very simple, guys, okay? The idea is we check if the two conditions are satisfied, and if they are, the series converges. One last thing. This test can only be used to study whether or not the series converges. If, for example, we had met the first condition and not the second one, we can't say that that means that the series will diverge. We'll need to use another test to evaluate this. So, the alternating test, which only works for infinite series that have this or this shape, lets you know if a series is convergent, which will be true as long as these two conditions are met. If either condition is not met, then we cannot conclude whether it will be convergent or divergent. Alright guys, so that's it for today. I hope you understood the video. If there's anything that you did not understand, please leave a comment in the comment section. I'm pretty sure that there will be more people that have the same doubt. So you can help yourself, you can help others. Please make sure to drop a like, comment, share the video, subscribe to the channel. We'll be posting videos almost every day about so many topics that could be very, very useful for you. I'll see you in the next one.